Hello and welcome everyone. My name is Dervish. I am from the Norwegian Java user group javaBin. This is our 9th online meetup in our online series. We have been doing this every week for almost 2 months now. And we represent the Norwegian Java community. We have regional groups all around the country in 8 major cities. Today we have with us Sven Ruppert from JFrog, who will talk to you about some high performance topics. So if you have any questions to Sven, please use the YouTube chat and we will collect them and we will get them answered for you in the end of the session. So Sven, welcome to javaBin, and thanks for being with us today.
Hello. Yeah, thank you. So let's start. I will start sharing my screen now, and then we can go on. So presentation. So can you see my screen? I hope so. Yes. Okay, perfect. So hidden field for Java high performance persistence. My name is Sven. I'm developer advocate at JFrog, and I'm mostly working with Java and Kotlin. So that's it. And this is now paired with DevSecOps. So why I'm coming to this topic? This is more or less the experience I had during the last few years that I'm playing around with persistence stuff. And I tried a few things, I learned a lot, and this is more or less, the abstract or the lesson learned from what I got to this topic. So what we want to do today is more or less, I want to have a short introduction of my bird's eye view about persistence. Persistence is a huge field, and I'm not covering everything, so that's for sure. But I have some points I want to focus on and to explain why I'm focusing on this one. And this is then leading to the basic question and thoughts I have mostly for me, if I'm talking about persistence, and some kind of projects I'm working on. Just mentioning a few words about this MVCC, and then I'm coming to the candidates I want to show you today. These are 4 candidates. They are completely different in some kinds, but similar in a few points. So this is more or less the content of the candidates, so that you can start playing around with this one. And then some ideas about persistence and DevSecOps or DevOps. So what you can do or what you should have in mind if you're playing around with this tooling stuff. The last thing is my personal view on a few things of this. So, but this will be marked very clearly what my personal ideas or views are and what are the official data. Then, if you want to have a cool shirt, what we have is the show notes. There you can find some additional information about this, additional links and all this stuff. And as well the slides, if you want to have them as PDF, for example. And then you can win here this shirt. I don't know if you can see it, but we have these frog shirts, different ones. I don't know exactly which one is the shirt we have this time, but there's this bit.ly link where you can just join and try to win. So persistence bird's eye view. Well, it's the bird's eye view or the persistence itself. So if you're thinking about persistence and if you're thinking about the whole thing, then you have tons of information. But there are some things that I'm mostly dealing with. So for example, if I'm starting from the app model or from the app itself, I have there my model, I have my nodes, my attributes, all this stuff, and I have to find a way to make it as good as possible for my business, for my use case I want to have my software for. And this means that I have my app model, I'm start composing stuff, I have a composition of data structures or core data structures that are part of the JDK itself. So in the end, I have a bunch of sets, lists, arrays, ints, bytes, whatever, and they are composing my app model. So far, it's okay. So I have all this, my business logic is working on this stuff. And then in a lot of projects, we have the first level that we are thinking about some caching stuff because things are slow or you think they are slow or whatever. So you have the first technical layer. And sometimes even this caching layer, it's very near to the business logic and business app model. But sometimes based on technical restrictions, you have to start mapping the model the first time. So some caches don't want to have complex data structures. They want to have plain lists. They want to have just class with a few attributes. They don't like, for example, graphs if you have cycles in your app model and all this stuff. So it could happen that at this level, you start changing your model based on technical needs. And this is just for the caching layer. And if you're going down because caching is not persistent, then mostly you have to deal with other technical things like inter-process communication with networks, all this stuff. And based on this, again, mostly a model mapping as well. So thinking about this SQL databases, you have to decompose your graph into tables and links between tables. And if you're going to other NoSQL stores, every time you have to map all this stuff. And this is time consuming. So you're wasting a lot of CPU cycles, you're wasting time more or less. And this is just work. So what can we do? And the main thing for me was always to minimize this mapping effort, to minimize the amount of technical layers. And quite often I can divide my data or the app data in several basic questions or basic parts. The first thing that really helps to decide which one would be the best or how to break it down is that you think about how stable is your data itself. So sometimes you have just a need to write down data like an event log, transaction log, events, whatever, just write it and you don't have to touch it really because you're not navigating through this data. You're just dumping it down. So this must be as fast as possible and it shouldn't be a huge technical thing. But you're writing it once and then you're just archiving it. The next step would be that you have a sliding window of hot data. So you have this, I don't know, the last 24 hours of data that you are dealing with. So you're navigating through, you're deleting, you're editing stuff, and the rest is archived. So you have a dedicated amount of data you have to handle. And the worst case is more or less that the whole data is hot. So you have your data pool and constantly all parts of your data must be accessible via query languages or whatever, or you are modifying all this stuff. If you're able to divide your data structures or your data from the app in these three categories, you can choose sometimes very efficient persistent layer for this dedicated part. And the next question you have to think about is mostly how to get this data back. If you're not just writing it down, but you have the sliding window or the whole data is hot, you have to think about if you want to access via SQL, Cypher, or just Java streams. do you need all attributes? Do you have to select one? Do you have a complex graph in the end that you want to load partially, and or lazy loading techniques, whatever. So the whole way of dealing with this data, asking for this data, manipulating this data. So these are very, very basic ideas. These are very clear and straightforward things. Mostly you can reduce the functionality you need for a lot of projects to one of these parts. So yeah, the technology should help you here. Just one thing to mention is that in the if you're dealing with data, you quite often hit the target of dealing with snapshots, dealing with concurrent modification of your data structure itself. This is a big thing, and this is not trivial. So this whole topic can fill up books, but a lot of these open source tools or persistence implementations, they are dealing with this MVCC. And if you want to learn a little bit more about it, I have to admit, if I'm digging in this content again, quite often I really have to read it again. I have to make all this knowledge warm again for myself, so that I really understand the first parts of it again. So it's nothing that's just easy and you have it present all the day. But if you want to read more about it, or if you have the need to deal with this data structures, because you have to implement this concurrency by yourself, then there is this quite old open source project. It's Poju MVCC. It's on GitHub. It's on Apache license, so you can use it for the most use cases freely. And this is more or less the implementation of this multi-version concurrency control. I added this Wikipedia link, so as first intro, but if you have to deal with this stuff, have a look at this one, start reading there, and try to understand how this snapshot technology is used. And this will explain a lot of things, pros and cons, from the persistence layers you're using, or I'm just mentioning here in a few minutes. Okay, coming to the first tool that is open source. It's I don't know how to pronounce it right. Maybe someone can help me with this one. Xodus, I don't know. I never asked this people. This is an open source project, and it's maintained and created by JetBrains. The people at JetBrains, they have really good developers, and they're very good in theoretical things, and they need it for their products. UTrack is a issue tracker, and JetBrains a hub. So it's the user management thing between the products. They needed a persistence layer, and they decided against the traditional one. So because they had some needs, it must be exit compliant. So you need transactions. What they want to have is a really good performance for reads, because they are estimating more reads than modifications or writes. So they are completely non-blocking. But the snapshot isolation itself is realized with this MVCC. It's a document-oriented database, more or less, because you have these buckets with attributes. And the key point here is why I'm using this one in this presentation is you can embed it completely. So you're getting completely rid of inter-process communication and network latencies and all this stuff, because it's just a dependency and you can ramp it up in your own implementation. Later on, if I'm talking a little bit about the security aspects here, this is completely written in Java and Kotlin, so no operating system calls, nothing. And the source code is freely available, so you can scan everything. And well mentioned, it's an Apache license. So if you start looking a little bit around of this project, you will see that you just need two dependencies for this. The first one is the API itself. It's a Xodus open API. And then you have 3 implementations. You can use in one module different implementations. You can. So it's not restricted to one combination of it inside your class path, as far as I know, but maybe someone tried it in different aspects. So the first implementation I want to have a few words about is the implementation about the environment. The environment is the lowest level you can have here for this persistence store. It's just a key value store. And what you have is more or less you have multi-maps or hash maps. That's it. If you say you have no duplicate keys and you have a hash map, otherwise you have a multi-map. And the thing is that everything is inside a transaction. Sorry, you have everywhere in transaction. So how to deal with this? You start this environment with a new instance. You can have different instances of this environment in your app. So as far as I know, there is no limitation. And then you're pointing to a file system location. Here it's just example repository. And then inside this environment, you start everything inside a transaction. So execute in transaction, you will get a transaction, and this transaction is just used, and you're just pushing this transaction to every call you're dealing with. And then you can open stores. A store is nothing else like an entity of this data structure. For example, here, the name of this entity is messages. So if you're holding this environment as a static one in your application, and you're calling a few times this get me or open the store, and with the same ID, then you have the same identity where, or the same store where you're working on. And with the transactions, you can just do this concurrently. And then what you have in mind here is you have this store, you have this multi-map key or this hash map, and then you're just pushing, put some keys, delete some keys, read some keys, and so on, or iterating. And what you should have in mind here that you must encode the values by yourself. So what you can do here is you have this string binding, for example, this class with some service methods to say string to entry or whatever. So you have to have in mind how to deal with data you want to save itself. If it is now how to represent it in a serialized form. But you have a transactional hash map or multi-map. On top of this one, you have the entity store. The entity store is more or less the next logical abstraction on top of it. So you have now your document, or they're calling it entities. And inside your document or inside your entity, you have these attributes. And the good thing is you can start linking this stuff. So you have your plain buckets that you're storing, and you can link and you can build a graph. Well, at least a tree with a graph. I haven't tested it fully if you really can deal with cycles in all consequences, but you can link this stuff together. And then again, you're just pointing with this persistent entity store to a position in your hard disk, and then you're executing a transaction. And here you just have to make sure that the transaction will give you a new instance of this entity with a name. So this is more or less the ID, the logical name, or whatever you need. And from this point, you're setting properties. This is clearly a document-oriented approach that you can say property A, value, property B, value, and so on. And this you have to do by yourself, but you have a transactional document store embedded, and you can link this one. And this linking is a really convenient one here. Okay, the next one is a virtual file system. The virtual file system is not on top of the last one. It's on top of the first one, so really on the key value store. So here it's optimized on dealing with streams, with blobs. So what they have in the application is they have these attributes, for example, for this issue tracker, you have these attributes of an issue, and then you have this attachment, and mostly this is used here for this attachment. So if you have pictures or blobs or whatever, and you want to store, then you can go here with a virtual file system. It's the same thing, just search for a place where you want to store all this stuff, creating this file system environment, and then per transaction, just create files and then stream data in, stream data out. So you have it divided between attributes and blobs. So you have to combine all this stuff later by yourself, or you have to decide which one you want to use. But the good thing here is you have just a folder, and if you're ramping down the app, if you're closing the app, then you can just make a tar gz from this folder and your backup is done. So this is very convenient, very easy. Okay, if you don't have the need for document-oriented stores, then there is something else very interesting. Some people will know it already. It's Chronicle Maps and Bytes. You have a little bit, a few more projects. Peter Lorre is the main developer there. And Chronicle Bytes, for example, I will start with this one. This is a really low-level byte implementation. So if you just have the need to write as fast as possible, or with low latency needs, you have to push data down to the disk as soon as possible, or as fast as possible, then this one is very interesting, because you have just raw data, you have a few bytes, you have a few ints and all this stuff, and you're just writing it down to disk. You can have it with off-heap implementations, and as you can see here, you're dealing with operating system calls, and that means with this implementation, you have to make sure that you have an eye on the JDK you're using. For example, the first one from JetBrains, you can just use any JDK, so there was no known limitation from what I saw so far, but here you really have to make sure if they are writing down, use OpenJDK 1.8 build number, whatever, it's a good advice to use this one, because everything that's going off heap or with system calls can just crash. But it is really, really fast. And then you have the same with maps. If you need a little bit more convenience, then you have this hash map. It's a key value store, and here again, it's just it's for really fast write downs. So how to use this one? For example, if you're starting with bytes, then you're adding only one dependency. The dependency itself has a bunch of transient dependencies. So make sure that you're checking all license behind this one, and checking for security issues, the whole tree, if this is a critical point for you. And then you have this class called bytes, and with this bytes, you can just use different byte buffers. Here I'm just using elastic heap byte buffer, and then you have a bunch of different others. So it depends the flavors between on heap, off heap, and everything else. So you have a bigger possibility here. So, and then you're just writing bytes. What it means is you need very clear knowledge about your data structure, because you're really low level at this point, because you're writing bytes and all this stuff. But it's very, very fast. And if you want to write it down to disk, you have this MapDB bytes, and then just locate a file somewhere and write it down. Now that's one thing. So this is for the need if you just want to write down data and don't want to navigate there. If you want to have a little bit more convenience, you can go to Chronicle Maps. And the Chronicle Maps is just one dependency again, and then the transitive dependencies, you will see there are a few. And here what you can do is you can start this map, and you have to have in mind that at this point you're creating this entity of this map. So the map will have an ID or a name, and then you have to say, okay, what kind of key and value you have. And here you have strongly think about serialization, and check there are a lot of utility classes there that will help you to serialize stuff, or follow up the documentation to to see what's going on here. So if you want to have values or complex attributes as a value, then make sure that you test it quite well. But you have a hash map, you can access it inside your whole JVM. And the main thing is that you need to know, if you're dealing with chronicle implementations, you need to know a lot about the data you want to deal with. It's really fast, but to be fast and efficient, you need to know the data, the amount of data more or less, for example, how many entries you're expecting and the average value. So a Java developer is not really thinking about this mostly, but here you have, for example, the average value will, if you're dealing with a char sequence or strings, then take a string that is in the average length of the whole amount of data you're storing. So if all strings are between 3 and 6 characters long, then decide which one is for you the middle and use this one as an average value. So not only from the length and from the value itself. And then just, again, create a file and dump down. That's it. And if you're done, just make a .gz and that's what you need. So here, what we don't have is transactions. So we don't have to, this is transaction mechanism. So have a look there, how this is working and how to deal with this one. But if you mostly just want to write down data as fast as possible, this is a very nice open source implementation you can go with. Coming to one other thing, and again, we are here on a quite low level implementation, means that here we are dealing with core data structures. Core data structure means that we're talking about hash maps, lists, queues, and all this. I want to mention this MapDB. MapDB is an open source project. And this is mostly maintained and developed by this person. And there are some things that are really interesting if you want to deal with some hierarchies of data structures. So for example, the document-oriented, so from JetBrains or the Chronicle part, they are more or less flat because you can't, or you have to build hierarchies of data structures by yourself. And MapDB will give you one interesting thing. Okay, so it's Apache license, so you can use this one. It's mostly written in Java, and no, Kotlin and a bit Java. It switches sometimes, so I don't know if it is now more Kotlin or more Java. But you can use it as a drop-in replacement for maps, layers, queues, and all this stuff. So this is really convenient. So you don't have to use just this data structures. And then you can have it in two flavors. You can have it in off-heap, on-heap flavor. So it depends more or less on your persistent needs and your risk you want to play with the JDK. And the interesting thing here is that it's a multi-level, or it's a multi-level cache. You have the possibility to cascade data structures with an overflow mechanism. I will show an implementation in a few minutes. And transaction handling is done again with MVCC. So with this, you can really have a commit and rollback on data structures itself. If you're dealing with a cascade of data structure, then you have to do it more or less by yourself. But you have on a plain data structure, like a map, commit and rollback. Yeah, that's here, how to use this one. You have just one dependency that's very convenient, and I think he has no dependency if I remember right. But I think it's just this dependency, not transitive one. And if you want to start writing stuff to disk, you have this DB maker. Then you're defining again the file or the place where the file should be placed in. Convenient is here that you can enable encryption. It's not part of the topic here, but you can enable encryption, yes or no, if you need it, just have it in mind. And then you are creating this DB. And if you have this DB, then again, you say to this storage or database, give me a tree map, give me a whatever map with a name, and then you have data structures or entities again of this data structure. What you see here is that you need for the key and values again serializer. So you have to decide which one you want to use. And the nice thing is he will give you a bunch of serializer already. And for the core data structures or data types, they're really good. But if you have needs to use a different one, you can just hook in with your own one. I think he has examples with Creo and whatever. I don't have everything in mind, but here again, you have to deal with the serialization stuff by yourself. And then you can create or open this map. And then you can just push data in. And what you can see here is you have a commit, you're pushing again something in, you have a rollback, and that's fine. So it's really easy commit and rollback here to deal with this. So yeah, that's here. Coming to the hierarchy. In a lot of applications that are running, you want to have the hot sliding window or the hot data in memory if it fits, and then just make sure that everything is persistent if you're adding some stuff or if you don't need it. And to implement this one with MapDB is really, really easy and convenient. So you're creating first the DB disk so that you have the place on the hard disk where you want to save all this stuff. And then you're creating with DB Maker a memory DB. So now you have a pure in-memory DB. And based on these two locations, you can create data structures again. So for example, if you're going to the disk one, DB disk, you're creating your hash map with name, whatever. And after this, you can create in memory the second one. And here you can start connecting both together. You can say you're expiring after, I don't know, 10 seconds or a second or whatever your need is. And then the data structure know that it should do something with the value. And if you say you have an expire overflow, a different target, it will push the data to this target. This could be an in-memory target as well. It could be a disk target. And then between disk targets, you can do more or less the same. Now, no, not with this one, but you can have different hierarchies and then you can push it to disk. If you want to have more control about the executor, you can allocate dedicated resources for this one, for your eviction strategy. And then you have a map that you can use as direct replacement for regular hash maps in your, or maps in your application with this hierarchy. So you're pushing some data in, you have this commit rollback stuff. And if you're committing, it's just committing down. If you have not enough space or data is old in your hash map, it will be just pushed, cleared out of the memory one, but it's written down to the disk already. So this is very convenient to build hierarchies, caches, stuff like this. But again, you're still on core data structures like maps, queues, lists, and so on. And yeah, well, and you have to deal with the serialization stuff. So I was searching quite a long time for alternatives, but this one was a long time my favorite, I have to say. But then I found a year ago an implementation from a German company. It's called Microstream, and this one is interesting. So the main thing here, it's free to use, but it's not open source. All the others are open source. This one is not open source. There's some of the points you may like or not, but it's free to use. So you can just go with this. And the thing is that this Microstream, they are, I don't know in detail how they are doing it, but they were able to work on the whole Java graph as it is and persist it or serialize it. So what you have here is you have no mapping anymore. So everything I showed before is more or less you have your app data structure, and then you're mapping it to the core data structures based on the technical needs from the implementation. So if it is an entity or if it is a hash map or whatever map or bytes. So here you have to do nothing. So it's just there. And the cool thing is that you can really do it with graphs, not only with trees. But, well, let's see. So to use this one, they are not replicating the stuff to Maven Central, maybe in the future, but right now not. So you have to add the repository from them, and then you have this embedded storage and configurations. They have a few other dependencies based on some features they're providing, but if you just want to play around with this, you can use this too. And then you have, again, an embedded store like all the others as well. And then you can start playing around with this stuff. How to do this one? You're creating a class, and there is no inheritance. There is no need of implementing some interfaces or inherit from some classes. You're just creating a class, you're adding your values, and here is no need to have getters and setters or naming conventions. So I tried it, for example, with immutable classes, just with constructor and getters. I tried it with this getter setter value with different naming conventions, so that I have no naming convention, just fluent style or whatever. So I played a little bit around, and there was no challenge here at this point. And if you have this attribute, and you don't have to get an entity managed by the persistence layer. So, for example, if you want to have a hash map from MapDB, you have to ask MapDB to give you ones. If you're doing it with Chronicles, or you always have to say, please give me an entity, and then I can work with this one. This is here not necessary. You have one storage shared in your application, and then you set a root value. The root value here is just the entity itself, but to have it a little bit more for the real life, what I've done is just I had a set, and then I had all the roots of my graphs I want to store, and then the root element was just the collection, and yeah, that's it. And then you just say store root, and then it's on disk. That's it, and you can shut it down and make a target gzip from your folder. So this is really convenient. So I try to break it a bit, and yeah. So what I would do is I would use collections as a root node, so that you have multiple things. For me, there was no need to change the model, so I could really just use a business model as I had it. But there is one thing: they have no transactions. So if you have to deal with concurrency, then you have to do it by yourself. But having in mind checking the implementation of this MVCC, then halfway is done if you need it. Dealing with huge graphs. This is a thing. Okay, this is one thing that is right now that I personally not really like. So is to have partial graphs, or this partial loading of a graph. You have to build this lazy reference, so a virtual proxy, into this model by yourself. So this is one thing. Okay, there must be a technical need for this one, but is the only thing that I personally don't like so much. But it's the only thing I know so far. One thing that's really interesting, you don't have to deal, or you don't have to detect if there are cycles in the graph. So there's just sort, and you have A to B, B to C, C to A, and you can just store it and load it. So there's no challenge here. So no inheritance as well. Yeah. So yeah, concurrency, if this is, and I assume this is a topic, then you have to look at this MVCC, just check the open source implementation, and it's halfway done. Persistence is just libraries to store all this data to disk is one thing, but there is a lot of things around. So for example, if you're dealing with persistence and DevSecOps or with the whole thing, for sure, what it looks like in your team. So mostly, well, you have the dev part, you have this ops part. So the dev part is just using plain core data structures. It's easy to handle, and the operating is just starting something because it's embedded. So this is quite easy. Handover could be just a jar. So from this point, there is no really a challenge with this technology. You don't have to deal with different knowledge at this point. You just go core Java. But thinking about security means that you should have an eye on security, not only in the end, if you have some attacks from outside, but the same during the development. And here, I don't want to mention some tools in special, but it's a good advice to check all transitive dependencies. Maybe now there is a small issue, maybe later there is no issue. Maybe you can fix this issue if you're overwriting some transitive dependencies. So I don't want to mention names because the situation is changing constantly, but you should have an eye on it if you're dealing with persistence. And the first thing is that you should have a view on it for security and compliance. So for example, if you have transitive dependencies or if you're dealing with dependencies, you should have an eye on this license stuff as well. And well, as a developer, I want to have it immediately. So I had to do it manually once for JavaScript environment. It was a little bit more work, so it's not fun. But well, from JFrog, we can give you some help with Artifactory, and then with X-Ray. X-Ray is just scanning everything that's in, and you should try it. You should try it in a way because you have to analyze the dependencies. The view is very convenient and easy to go through. You can have some web UI to try it. So add your dependency and let it check. But well, feel free to reach me out. So some random thoughts. The main thing, if you or how to come to a decision, what is the right persistence layer for you, or what is pro and con. So if you're dealing with big persistent systems, and if the persistence is, so all the solution I showed you, there's one limitation. It's running on one system. If you want to scale, for example, then you need some kind of technology if you want to go over different nodes. If you're dealing with core data structures, for example, Hazelcast is a very easy and nice thing to go. Then you have your hash map, and the hash map is persistent somewhere, and so on. So you can stay a quite long time in core Java, but a lot of systems don't need to scale over different servers. It's just enough if you have one machine. Well, maybe the project, it depends, but I saw a lot of projects that don't need it. And then you can do everything on one machine. So a small amount of components is mostly easier to handle, not only in operations, but even during development time. Think about TDD, for example, test containers. Test containers is a really freaking cool open source project. I really love it. So you can ramp up a Postgre database in seconds, but it's in seconds. With this in-memory solutions, I just run the 10 amount of time, or the hundreds. Yeah, so I can run more tests in the same amount of time. So it's factor 10, factor 100. It really depends on the implementation and stuff, but you can really easily ramp it up, ramp it down. And the good thing is, with all these binaries, having in mind, you're storing this stuff on disk. If you want to share, for example, data sets between developers, or have reference data sets for version, you have a long-term support version and you have to maintain these long-term support versions, then you can just have a repository like Artifactory, these generic repositories, and put these binary dumps in. And from every machine and the CI environment, you can just load this binary store and have your tests running with this immutable data. So this is data-driven testing. It's really convenient. So this is good. Data migration. This is a weak point with all this stuff. So if you have, for example, if you have a database like Postgre, then you have a dedicated migration path. Here with these solutions, you have to read carefully how to migrate data between version A and B. Sometimes it's just smooth, and sometimes you have to deal a little bit, and then mostly you have to deal with coding some stuff or whatever. So test it. If you're running into issues, just make your decision. But the good thing is, if you're completely in the Java world and Maven dependencies, everything is there, license checks, even about transitive dependencies is easy. So you're safe from the business point of view, and security checks can be done immediately as well. And then if you have something, you can just override sometimes transitive dependencies and the thing is gone. So managing everything in the Java world with this embedded persistence, the good thing is the CI environment is easy to ramp up, fast to ramp up. The IDE support for all this is great because you have just auto-completion and all this stuff. But if you want to have ad hoc queries, for example, if you have a Postgre and you're going just with a SQL tool on it, you can just navigate through all tables and you can play around and you can have a look at it. Data navigation and then ad hoc queries with all these tools is a little bit, it's not so convenient. So have in mind that if you have to deal with this one and if you have to check if some data is corrupt or whatever, mostly it ends up that you're doing it with code. So to ramp it up, to check it, to manipulate it and all this stuff. On the other side, backup and restore is very easy. You have just start GZ, you're packing it or unpacking it, and that's so from this point, it's easy again. My personal view and pros and cons to these solutions I have here. So it's really my personal view. So I'm really happy about questions or some suggestions, or if you worked already with some of this, please give me feedback. I'm really eager to hear it. But if you're going to document-oriented stores, even if you have to deal with blobs, and this is really the nice thing with Xodus, that you easily can handle these blobs as well. So if you want to build a transactional image cache for pictures or stuff like this, this is really nice thing. So if you have attributes and you're just storing this stuff. So for this, it's really nice to deal. The API is a little bit, well, some people like it, some people like it more, but you have to get used a little bit to this API, but it's a good one. If you just want to write down events or transaction logs or whatever, just as fast as possible for compliance or whatever needs, then Chronicle is a good advice. Just raw data as short and compact as possible and just dump it down to disk. This is a really, really fast thing. You can buy support, for example, if you need it for your company, you can go to Peter Lorre and just buy support. It's the same with Xodus. So you have a company you can ping, you can ask. I think you can't buy support, but they are not slow with bug fixing. So because they need it by themselves. So that's it. MapDB. I personally like MapDB as soon as I have to implement some caching strategies or stuff like this, or if I have embedded systems, for example, a Raspberry Pi or whatever, and I really have to deal carefully with memory, then MapDB is a nice solution. So because you have this overflow, this robust, you have transaction handling, so this commit and rollback and all this stuff. There is one point, actually it's a version 3, and there is a version 4 planned, but I think it's planned since 2 years or so. So MapDB itself it's a really great open source project, and I really like this project. But if it is mission critical, check if this one is running for you, and if you have issues with bugs or whatever, then have in mind that you have to fix it maybe by yourself, because sometimes it's a little bit slower. It's a great project, but it's a one-man show. So have in mind. I don't know if you can hire him. I think he's self-employed. I'm not sure completely, but I think he's self-employed. So maybe you can hire if it is a bigger project. But yeah, so try it. It's really nice. but don't wait for features on the roadmap. So it could take some more time. Microstream, okay, you don't have the source code. This is one of the points I'm personally, yeah, well, it would be nice to have, but well, it's free to use. You can buy support. This is what the company is doing to earn money, for sure. The convenient thing is that you can have quite complex Java graphs, and you just write it down and read it, and they're really fast. So it's not slow what they're doing. They are young, so all the other projects are quite older. So they're existing a longer time, so 5 years, 6 years, 10 years. But Microstream is quite new, but you can buy support. And I think the convenience is one of the highest here from all this stuff. So if you have to navigate, for example, then this is good. If you want to filter with streams and all this stuff, Microstream is just nice. Yeah, so this, if you want to try out all this stuff and to analyze it, I really would appreciate if you're going to the cloud and start a free trial. Why? Because you have not only the Artifactory, you have access to X-Ray. And X-Ray will give you the possibility to check the security stuff. So what I've prepared here is, you see the URL I showed you here. This is on GitHub. And there I created a multi-module module project in Maven so that you just can clone it, and then you can just play around with this. You can just, so the dependencies are there. You can just analyze the dependency tree. You can analyze what there is. They are not big examples, but you can just start with your hello world in this different modules. So you can directly compare the API and all this stuff by yourself. If you have suggestions or whatever, just make a merge request, ping me. I'm more than happy to add examples. And what you should do is, in the trial, just create a Maven remote repository, change the value in the POM and use this remote repository, and then you can just analyze the dependencies, the license, all this stuff, even with the ID integration. So then you have your own point of view here. I collected all URLs, so you can just go here and check. So Microstream is from the company, but then this JetBrains, MapDB, and Chronicle. This is the thing. Then we have this javaBin JFrog. Yeah, I remember there was something win a frog shirt. So if you want to win the frog shirt, just go here. And I think my colleague will inform you quite soon if you got one. But more or less, I'm done with the presentation, with the planned parts, and I'm ready for the Q&A. So I'm really happy for being here and to explain this. And I think we can start with Q&A. Oh?
Thank you very much for the presentation, Sven.
Yeah,
let's see. I have 2 questions.
Okay.
The first one being, will the slides be available?
Yes, for sure. Go to jfrog.com/show notes. I think there we are collecting all this stuff. If you have a place for yourself, we can push it just there. And well, you're able to get it. Otherwise, just ping me on Twitter.
Yeah. The second one was, is the code available?
The code available. Which code you mean? So from the open source projects? Yes.
The code on the slides, probably.
Yeah, yeah, I think it's as example in this GitHub repository. Otherwise, yeah, I can just give you this one and check the README from the project. Basically, you will find good example there as well.
Yep. And that was actually it. There is no other questions.
Okay.
So I just wanted to thanks to everyone who has followed us this evening. This was actually the last meetup before the summer. We will take a short break now, and we might return with the online series again after the summer. And thank you, Sven, and thanks to JFrog for the cooperation on this meetup. And to everyone, have a nice evening and stay safe. So that was our stream. And have a nice evening and goodbye.
Okay, bye.